All right, for lesson 113, we're doing something completely different, something you've not done before. So it's a good idea that, I guess if you're already watching the video, then good for you. I'm glad, because you need to watch the video on this one. We are talking about two different things, direct variation and inverse variation. And you'll see this again your next year of algebra and pre-calc and all that. It'll get used again. So in a nutshell, the concept kind of goes like this. Suppose that in every classroom at a particular school there are twice as many boys as there are girls. We can express that by writing B equals 2G, where B stands for boys, G stands for girls, so we have to double the girls to get how many boys we have. Okay, let's say in another school, there are 3 times as many boys as there are girls. It would look like this. All right. Now, the standard or the general form, we call this a constant. The 2 and the 3 are called constants. Well, that constant could be written like here's the general form of that statement. The constant, we use the letter K for when we don't know it. G. So let's say we didn't know what this was in any particular school. So then it would be written like this. And here's how you would see it in writing. Whenever we have a relationship like this, where one variable is expressed as a constant times another variable, is called direct variation. Okay? You will see it as written like this: direct variation, or we would hear or see direct proportion. These all are synonymous to each other, okay? And this is the constant of proportionality. Let's see if I can spell that. Lots of letters. Good job. All right. Yes, I just say good job to myself. When we are doing a problem like this, so I'm just giving you some background. I think it'll all make sense when we actually do the practice. But you might see we were talking about the boys and the girls. We would say that the number of boys, go back to this. Okay. The number of boys varies directly as the number of girls in the room. Okay. Or we would hear it be written, or hear it be said, or see it written as the number of boys in any room is directly proportional. Okay, so if you ever see these two statements, it's kind of like a big flag that we are doing direct variation, and you're going to use an equation like that. Okay. Before we can solve any problem, though, we need to know the constant of variation. So we need to know what our K is before we can solve a problem. And so let's go ahead and talk about, let's say if we are told the number of boys in any room, any classroom, is directly proportional to the number of girls. So that's the first statement. And then so that we would know this. Once we see that statement, we write that. Then they might give us more information. They can also, the next statement would say we can use these values and solve for K. If there are 30 boys and 5 girls in one room, so they would say boys vary directly with girls, and there are 30 boys in one room and 5 girls. So we plug in those values for your boys and your girls. And now we have what we need to solve for K. We would K is 6. Okay, so that's how we would find our constant. Sorry, I'm kind of using the book's explanation too, so that's why I'm being a little hesitant. I want to make sure I cover what I think is important. The next part of the book, because in your notes I said to just read. I'm just reading it with you. There's other statements where we might see, like, we might read the statement, the weight of a substance varies directly as the volume of the substance. And so right when you read a statement like that, the weight of a substance varies directly as the volume, you would say W equals KV. Okay? So you read a statement and you can write out an equation. It's we might hear force varies directly as the current. Force varies directly as the current. Or the distance traveled varies directly as the time. We've kind of seen that before. It's usually an R. Okay. The words directly proportional mean the same thing. So let's say we read, the circumference of a circle is directly proportional to the length of the radius. Okay. Or we would read, the volume of a right circular cylinder is directly proportional to its height. Okay, so let's do some practice and put this into action so we can make sense of it, shall we? Okay, I'm going to go on to your notes. So you should have these printed out. All right, and let's look at this first example. The mass of a substance varies directly as the volume of the substance. So you might say, okay, we've got mass, we've got this thing here, varies directly, and volume. So how would we write that as an equation? Hopefully you're thinking, oh, it's M equals KV. All right, then we read the next sentence. If the mass is 10 kilograms, what will the volume of 35 kilograms be of the substance? The mass of 2 liters of a substance is 10 kilograms. So the mass is 10. The volume is 2 liters. We could figure out what K is. Now, K, our constant, is 5. So what we now do is look at the question. What will be the volume? What's the volume? So we're looking for this number. If the mass is 35. So you'd say 35 equals, we use our K now, 5 times V. Okay, so what can we get? What's the volume? The volume is going to be 35 divided by 5. Volume is going to be 7 liters. Okay, so that's how we put this idea into practice. Let's try it on another one. The distance traversed, that just means traveled by a car. So the distance traveled by a car, that's why they probably use traverse, because then they use the word traveling. The distance a car went traveling at a constant speed is directly proportional to the time spent traveling. So the distance is directly proportional to the time. There's our equation. Now it says if the car goes 75 kilometers in 7 hours, how far will it go? Oh, I'm sorry. I'm having trouble reading today. It went 75 kilometers in 5 hours. How far will it go in 7 hours? So first we got to figure out our K. We divide. Okay. So 17 divided by 5 is 15. So our K is 15. Now we use that to answer how far will it go in 7 hours. So we don't know the distance, but we know K and T. So 15 times 7 is 105, and it's kilometers that we were looking for. Okay, is this making sense? I hope so. Example 3. Under certain conditions, the pressure of gas varies directly. So pressure varies directly as the temperature. So P equals KT. When the pressure is 800 pascals, the temperature is 400 K, which means kelvins, not K as in the constant. Okay, so K times 400. What is the temperature when the pressure is 400? So first we got to find our K. Well, if we divide, we get 2. So our constant is 2. Okay, so that would mean, let's take what is the temperature when the pressure is 400. Now I'm just using parentheses. I don't know why. Sometimes I overuse them. It depends on my mood. So obviously I'm overusing them today, but that's okay. All right, divide by 2. So 200 kelvins is the answer. All right, now you see I have more information to give you. It's just talking about inverse variation. So what we just did was direct variation. Inverse variation just means that your original equation is set up differently. Okay, so sometimes now we're going to see, we saw varies directly. Now we're going to talk about varies indirectly. Okay, or it's inversely proportional. That just means our equation's going to look a little different. Let's say we're talking about V and W. Doesn't really matter, but let's say volume varies inversely to the weight. It looks like that, where the constant divides the other variable. Okay, so just so you remember, this is direct. It would be, if they were directly proportional, it would look like this. Okay, inversely is this equation. That's the only difference. The statements they give us, examples are: the pressure of a perfect gas varies inversely as the volume, or the current varies inversely as the resistance, or the velocity is, yeah, you can see that you're going to be using this in the sciences too. Velocity varies, well, they're actually going to say velocity is inversely proportional to the time. Okay, so those are real life examples. We're going to use it. So now I'm going to go back to my notes. Like I said, this is just, we follow the same route as we did on the last one. It's just different. The equation looks like a fraction rather than a multiplication problem. Okay, under certain conditions, the pressure, oh, we already talked about this. The pressure of a perfect gas varies inversely as the volume. So there's our equation. When the pressure of a quantity of gas is 7, the volume is 75 liters. There it is. Can we find K? Yes. We multiply both sides by 75. Okay. And 75 times 7, I'm totally cheating. is 525, so that's our K. All right, now it says, what would the volume be if the pressure's increased to 15 pascals? So now we have 15 for the pressure. We now know it's 525 for the K, and we want to know what the volume will be. Okay, how do you solve for that? The way we do that is, I'll show you the long cut and the shortcut. You can multiply both sides by V, get the V out from the bottom, right? So 15V equals 525, and then divide by 15. And when we do that, we get 35 liters. All right. Also notice what happened is these two basically can switch spots and cross over the equation. I don't know if you noticed that. So we found that we got V equals 525 over 15. So that's something that you might not notice until Algebra 2. But do you see how I multiplied both sides by V to get V out of the denominator, then divided by 15? Okay? But I'm just telling you, there is a little bit of a shortcut if you understood what I just said. If not, stick to that way, because I don't want you to get stuck or get the wrong answer because of that. All right, the last example. To travel a fixed distance, the rate is inversely proportional to the time. So the rate is inversely proportional to the time. There's our equation. When the rate is 60 kilometers per hour, the time required is 4 hours. Okay, how do we find K? Multiply both sides by 4. 240 equals our constant. Now we substitute. We see, where are we? What would the time be required? So we're looking for T for the same distance if the rate were increased to 80 kilometers per hour. So now we have 80 equals 240 over T. Again, my T and 80 can actually switch spots because he's in the numerator, because you know he's right like that. Denominator, these two can switch spots. So T equals 240 over 80. Now that is true just because what I did was take 2 steps and put it into one. I could have multiplied both sides by T, so that it would have been 80T equals 240. Then you'd have to divide by 80, and you'd end up here. So, all right, 240, 24 divided by 8 is 3 hours. Okay, so you got 3 practice problems on that. I would do them right away, and make sure you understand how to do this. Again, call me, or text me, or email me if you get stuck. And have fun. We only have a few more lessons left, so do your very best. Don't get behind. All right.